So it was hard to actually get everything into one sentence here, but I think I managed somehow. So, you see, I'm by myself here on stage. I was supposed to be joined by Jenny Björneberg, but unfortunately, just before we should go here, she went ill. So that's why I'm here by myself today. So my name is Emil Backmark. I work for Ericsson as a CI/CD architect. I've been working for Ericsson for over 20 years, and mostly in the tools business. And since the early years in this millennium, I've been part of creating the architecture for the production machines delivering software to our mobile network nodes for GSM, 4G, and now 5G. As you can tell, English is not my native language. I'm from Sweden. But I still believe that you will understand the message I will broadcast in this room today. There we go, the agenda. So in this session, I will go through some of the challenges that we've had in our CI/CD journey within Ericsson. Then I will try to relate those challenges to challenges that we see when integrating software between open source communities. I know that you represent a lot of communities in here. And then after that, I will share how we tackle some of those challenges, and finally suggesting how we could together proceed in tackling the multi-community integration challenges. Just a few words to begin with on what Ericsson is for you who don't know us that well. Ericsson has been a telecoms network provider for over 140 years. We're a global company of almost 100,000 employees worldwide, out of which about 10,000 in North America. Since several years back, our main focus has been on developing and delivering mobile networks, and we're one of the major players in the current 5G race. So why are we then interested in CI/CD, you might wonder? Well, we are to a large extent a software company. We produce a lot of different deployment variants, as our customers have very diverse needs, since they range from operators providing high coverage services in rural areas to those providing high capacity services in metropolitan areas. We also have customers running continuous deployment to live networks. And we are users of CI/CD. We are not providers. But as users of CI/CD, we see that we can provide some valuable input to those of you who develop CI/CD services and products. So let me start with a question here. How do you today find out that there is a new release of that cool open source project that you are integrating into your application? And how does your CI machine find out? We'll keep this question hanging there for a while, and I'll come back to it later. And instead, I will present some of the challenges that we've faced in our own CI/CD journey with a short history lesson. I'll try to make it short so you don't get bored. Anyway, let's look back 10 to 15 years, like so. Those of you who were in the business by then probably will recognize what I'm about to say right now. We had waterfall development. We had specialized teams, development teams, integration teams, system testing teams, and so on. Not much automated integration and system tests by then, and very little deliveries between teams and between products that was automated. So in best case, we had like this, cron jobs to the left that were running, scheduled daily maybe or something, doing some stuff, testing some things. We had test scripts based located on shared folders on some server somewhere. After that, we started to deploy more advanced tools, and we started to use Hudson, that some of you might be familiar with. We replaced our cron jobs then for the regression tests with Hudson jobs. And the development teams sometimes trigger the unit tests on source code changes. By that time, we used ClearCase. How many of you are familiar with ClearCase? Nice. That was a great tool. And we actually still use it in some parts of our business. Automated integration started with development teams and integration teams connecting their pipelines together. But integration and system tests still were mostly scheduled. The test scripts also were started to be moved to source control management, which was a very good thing, enabling to also trigger pipelines on those changes. Soon after Hudson, You all know Jenkins came in and replaced Hudson. So they did for us. We moved from ClearCase to Git for a lot of our operations. And more of the test code was also then added to Git, since Git was an easier way to run your source control management than ClearCase was. At this time also, continuous integration became a buzzword. And automated interaction increased when system test teams connected to integration teams' pipelines, so we got some more interaction there. We got reduced manual handovers with these automations and decreased time from commit to quality tester products. And then the interaction points grew even further as more dependencies were integrated. With that, of course, the quality increased because we got more automation and more precise predictions also of the delivery process, which is all good. It increased the ability for us to react to the market changes and also the possibility to bring new features and corrections to customers faster. But with added integrations, the chain became brittle. And on top of that, we had, as you see, a lot of team-specific Jenkinses managed by the teams themselves. And that was mitigated by introducing centrally managed Jenkinses instances. But still, each team had their own needs for plugins, which I guess most of you know could be a burden to handle. It seems to be no end in these increased integration points, and it still is the case. We continue to integrate more and more teams, more and more products. We have teams in multiple different time zones. Each of those teams with their own needs of builds, integrations, and different tool chains. It has been very hard to get an overview of where your commit is. So if you have, in the development team, created a commit, it's hard to know how far in the delivery chain has this commit come to get a total visualization of the whole picture. A lot of manual work was needed to figure out the configuration management part. What did the release contain, and how well tested was it? And also with this increased automation, we got increased demands from the market to react quickly, yet of course with top quality. And this setup does not scale. We need large-scale continuous integration and delivery. And we need to integrate small changes often with fast feedback. So now the history lesson is done. You can wake up if you was sleeping. Just to summarize the challenges that we've had now. We have hundreds of teams and hundreds of products, and it's increasing. They all have connected pipelines. We have several different tool chains with non-standard interfaces between them. We have different ways of working in these teams. And we have very high demands on visibility through the whole chain, traceability, performance indicators, from commit of the lowest library component all the way up to customer deployment of our applications. The same demands also include open source tools in the pipelines. So one idea, of course, is to pull towards the open source projects, but it's not sustainable, as you understand. Using webhooks then, well, it's not really an option for us as we cannot open such ports into our intranet. So we need some other solution. What about you? Do you recognize this picture, these challenges? Some of you do. Well, I believe so, since the topics of integration and interoperability has been identified as one of the strategic goals for the CD Foundation for this year and the next. I know Christer said this morning that there should be no talk about this number 3, but this is actually talk about number 3. So let's relate now to the challenges that I've described to those of the open source communities. In this picture, you see 3 different products. To the left, you have some cloud infrastructure software. It could be, for example, OpenStack. We have the cloud orchestration software, which could be Kubernetes. We have some cloud application software. It could be Jenkins X, for example. These are all somehow dependent on each other in one direction at least. It would have been easy to integrate these tools, of course, if they all share the same tool stack and they can communicate natively with each other. But as you know, the CI/CD landscape constantly evolves, and there is no solution. There probably will be no solution to rule them all. And the trend is that the number of integration points will increase. Previously, we had these physical servers with some operating system on them, and then you compiled your application on top of that operating system, and that was it. So it was one hardware layer and two software layers. But now, a software stack could contain dozens of interconnected software layers, also multiplying then the integration points between all these layers. Let's look into some operations in the pipelines of these products. Say there is a new version of this cloud infrastructure service software. It is to be picked up by the make system in the cloud orchestration software and built there. And then it should be integrated into this cloud application software, maybe that's component that is built. And also, the cloud application software developer organization would, of course, like to know how well tested this component that was built is. So, also, what about high-level questions on these operations, like that of the cloud infrastructure guy? Has anyone integrated this new library into their software yet? And was it successful? And maybe the cloud application software guy could ask, has the new cool infrastructure software feature that we knew of been tested in the orchestration software yet? And maybe the orchestration software guy could ask, how often do people integrate these components that we release that frequently? And we could stretch it even further, maybe, that the cloud application software guy could ask, is my application deployed on some AWS cluster somewhere? Answering this could, of course, again be simple if all was in one tool stack, but the reality is different. We don't share the same tool stack, and thereby we don't automatically understand each other. Most tools have their own custom interfaces and languages. I'm pretty sure that no one here can understand all these languages. We could, of course, integrate point-to-point with plugins between these components, these pipelines, and translate the languages between those. But we should probably look for a more sustainable, more generic solution. And most of you wouldn't understand if I started to speak Swedish now. Ni har nog inte en aning om vad jag pratar om just nu. Och ni funderar säkert på om jag säger någonting dumt. Det drabbar ju både er och mig när ni inte förstår vad jag säger. So, with that said, a common language is crucial if we should understand each other. Now back to this question. Bra. What about using broadcasted events sent as messages on a message bus to signal a new release? And apart from signaling new releases, many other of the challenges can be dealt with. So instead of subscribing for release mails, polling the websites of the product, or waiting for some tweet maybe announcing a new release, the CI machine could listen to events. And when your CI machine knows, you will know as well, of course, because you're probably monitoring your own CI machine. So what is then our story on using events within Ericsson? We started long before the picture grew this complex. We started to send events internally, notifying new builds, notifying artifacts being uploaded to a repository, notifying the quality level that a certain artifact had reached. After each test activity, we also sent events. And the people integrating the software down the chain could then decide on what well-defined quality level that they wanted to integrate that upstream product from. The event protocol was agnostic to underlying technology stack. We could replace the technology in that stack without affecting interconnected pipelines and other consumers of that event data. We created a high-level language whose words were also used when talking to each other in our fika rooms, which was a very good bonus. The language evolved over time to include more and more notifications. And one important aspect of this protocol language is that the events are linked together, forming a directed acyclic graph of notifications from the CI/CD domain. This linking made it possible to visualize and measure the pipelines in a tools-agnostic way. A more or less real-world example is shown in this picture of such visualization with ongoing and finished activities through our network of pipelines. This is just one part of it. We believe that events can help also when tackling similar challenges in integrating software between different open source communities. So let's now go back to this picture. What if broadcasted events were used here? The dependencies between these components, these products, could be automatically updated based on the information in those standardized events. And then, on that, your integration flow could start testing them automatically. Today, I believe that a lot of you still manually tell the CI machine to integrate a new upstream release by, for example, updating a make file, updating a POM.xml file, or similar. But let's now bring this to some well-known ground for this CD Summit. This is a simplified picture, yet showing some dependency integration points. I'm not probably 100% sure of all these dependencies. You are very much well aware of them. I'm not a user of all of these. Anyway, I'm pretty sure that these are not using the same CI/CD toolchain, right? So a common language could play an important role here. And instead of point-to-point integrations between all these software open source communities, indications could be done with broadcasted events instead. The event producer doesn't connect directly to a consumer. We could have a shared or federated message bus that forward the events to the interested parties. The event consumer then decides what upstream pipelines to listen to subscribe to. And with this, we could also answer a high-level question like that of the OpenStack guy. Has Kubernetes integrated our new version of this library yet? And was it successful? And maybe a Tekton developer could ask, has that new OpenStack feature that we heard of been tested in Kubernetes yet? And maybe a Kubernetes guy could ask, how often do people integrate these components that we release so frequently? And a Cloud Foundry guy maybe could ask, has Spinnaker used this new feature directly from us or through a Kubernetes delivery? In addition to this, we could also visualize and measure and analyze data from a network of pipelines over multiple communities with these events. And furthermore, a large community can probably be compared with the development setup we have in Ericsson. And then it can be used internally within the community, these events. We could have events to trace features, bug reports, software updates, internal pipelines. And we can still connect them to the external community pipelines then, if those exist. This would also enable a smooth migration from one CI/CD toolchain to another, if needed, within a community. And you are the one that decides if messages should be federated out from your community message bus or not. Then you might wonder if anything like this exists. Well, this is our version of it. It's called Eiffel. It's an open source. You can go there to look if you like. This protocol that we are using has artifact events notifying that new artifact versions has been created, published, or verified. We have source code events notifying that something is pushed or merged in our source control management system, or a new baseline is created. We also have activity events, starting and stopping our pipelines, pipeline steps, and test case execution and such. And today we send over 2 million events per day. That is about 30 events per second, which is a powerful resource for machine learning and AI, if you're into that business. We saw this picture this morning, and I propose to add some communications or interoperability section to this picture, where these multi-community integration challenges could be dealt with. To finish off, again, this picture. Should we collaborate on a tools-agnostic event protocol within CDF? Primarily focusing on the protocol itself, not the specific tool set underneath it to handle this communication. And that brings me to the questions and answers. Any questions? Comments? Yeah.
So what you presented, do you find that different than what we're starting to hear as value streaming? Where you're trying to coordinate multiple tools and have those tools communicate upstream?
I guess it's in the same area. You asked about value stream management, if that's the same thing, or yeah. So, yeah, I guess it's more or less there.
This is an area we talk about a lot, getting the tools to be more interoperable.
Yeah.
Could you go back to this landscape? I want to see how you think.
I don't have it in oh, sorry. It's not there. This is the region picture, so I didn't add it.
You're going to do a pull request.
Maybe. I could. Sure. Yep.
This is almost like service bus for DevOps, I guess. What key things did you see when you were doing IT right now? Things that are already out there that are well defined for applications.
Could you repeat the actual question?
What is unique about what iPhone brings to the table that we didn't see from things like service bus, communications, and applications? There's a lump sum subscription model we've all seen.
I guess the unique is that we define this high-level language that everyone can understand, and all tools could integrate with using this language. So as the language protocol itself is what we haven't seen anywhere else, at least, when we started to do this. Now, of course, there is something called cloud events, you might have heard of, and that's probably a good start for this. But to me, cloud events is a bit low level. I think there are something called cloud events extensions, and maybe this could be something like an extension to cloud events where we define this high-level language. Okay, more questions? Crystal clear. Thank you.